This is Geometry Unit 8, Lesson 2, Proving Triangles Similar Using Angle-Angle Similarity. Now, just to review what similar means, two figures are similar if one is the image of the other after similarity transformation. In similar figures, all corresponding angles are congruent, but all pairs of corresponding sides are in the same ratio or in proportion. So, in order to prove triangles to be similar, all their angles have to be congruent, and all their sides have to be multiplied by or divided by the same amount. So that's what it means. So the angles have to be congruent, the sides have to be in proportion. Now, as with proving triangles congruent, if we can prove certain characteristics about similar triangles, we can say they're similar. When we did congruent triangles, we didn't have to prove all of the angles and sides, we just had to prove certain ones. Well, the same thing is true when we do similarity. And the first similarity theorem we have is angle-angle similarity, which is abbreviated AA with a tilde. It says if two angles of one triangle are congruent to two angles of a second triangle, then the triangles are similar. Basically what this says is if you can prove that two pairs of angles that correspond are congruent, then you can say the triangles are similar. So let's do a similarity proof, similarity transformation proof to show why this works. So let's prove that triangle ABC, which is this triangle right here, and triangle DEF are similar using a similarity transformation. We're going to use angle-angle to prove that. So, we are given triangle ABC and triangle DEF, where angle A is congruent to angle D, right there, and angle B is congruent to angle E. Those angles are congruent. So, we want to show that these two triangles are similar when you just have the two angles that are congruent, or corresponding angles that are congruent. All right, so if we're going to use a similarity transformation, the first thing we want to do is we want to get them to line up. So, let's do a translation along AD. So I'm going to go from A to D right there. That is my translation from A to D. So A becomes D, and then B becomes B prime, because it ends up here, and then C becomes C prime, which is over there. So we have already proved now that A will correspond to D. So that's my first point. Now, I'm going to rotate counterclockwise around D until DB prime, this segment right here, coincides with ray DE. So it's going to correspond, it's going to go counterclockwise like so that DB prime right there will end up at DB double prime right there. It's going to be on the ray DE. So what does that work for the points? Well, B prime ends up at B double prime. And C prime ends up at C double prime. So when you swing this around, it comes out down here. Then we want to reflect over DE. So we're going to flop this over DE. And remember that we know that B double prime DC double prime is congruent to angle EDF, this angle right here, because when we flop it over, the angle measures are still congruent. So these two angles right here will be congruent. And the image of ray DC double prime will coincide with the ray DF. So this segment right here, DC, will be on the segment DF. It'll still be on the segment. It's not the same length as DF, but it's on the segment DF. Now, here's where we have to do the dilation. All right, because we want to make it bigger, we want to dilate with center D by the ratio of DE becomes DB prime. So what we're going to do is we are going to take the ratio, the bigger segment would be DE to the smaller segment DB right there. So we're going to dilate it by that much so that DE or DB prime, double prime becomes DE. So it's going to make it twice as large. Or not necessarily twice as large, but larger than it was originally. So the bigger image would go first, the DE is the longer side, and then DB double prime would be the smaller side. So we're going to make it bigger. Now by doing the dilation so that DB double prime becomes DE, that means that B double prime will now become E. So that becomes E. And since we know that these two angles right here, DB double prime C double prime, and these right here are congruent because the angles stay congruent when we do the reflection. Since those two angles are congruent, that means that this B double prime C double prime will coincide with this right here. So those will coincide there as well. And by making it bigger, doing the dilation, it'll now be out to here because we made this bigger by sliding it out here. We made it bigger, it ends up out here. So B double prime, C double prime ends up at EF. So that means now that B double prime will be E and C double prime will now equal F. So C triple prime, equals F. So now we've proved A becomes D. We proved that B double prime became E and C triple prime became F. So each of the points of ABC lines up with DEF, so the triangles are similar. So it's just like doing a congruence transformation, except we had to do a dilation to increase the size, the length of the side. So these two triangles are similar using a similarity transformation. The image of ABC is DEF because of the similarity transformation. So the two triangles are similar. All right, so the similarity theorem that we just talked about is if we can prove two angles congruent, then we can say the triangles are similar. So angle-angle similarity is what we're trying to prove. So let's look at the two triangles we have. We have triangle RST and we have triangle RPQ. Now, obviously, those two triangles are not congruent. You can tell just by looking at them that one is larger than the other. If I sketch them out separately here, so here is RST, and the other triangle is going to be RPQ, which is the larger triangle. All right, so here's my two triangles. I'm going to label them RST and RPQ. Okay, now, the triangles are overlapping, so you can see that's the two I'm looking at for the two triangles. I want to prove that two angles in each triangle are corresponding angles are congruent. Well, if I look at angle RST in this triangle right here, which would be right here, what angle would that be in the other triangle? Well, that would be RPQ, which is this angle right here. Now, with these lines parallel, that's what that the arrow means right there, are those two angles congruent? Yes, they are. So we can say angle RST is congruent to angle RPQ. Because what kind of angles are they? Because if lines are parallel, corresponding angles are congruent. Okay, now is the same thing true for RTS and RQS, these two angles right here? Yeah, it is. So I can also say those two angles are congruent. So angle RTS is congruent to RQP for the same reason. So I have proved that two pairs of angles are congruent. So that means that the two triangles, triangle RST is similar to triangle RPQ by angle-angle similarity. I've proved that two pairs of angles are congruent. Okay, so let's take a look at these two triangles here. We have ABE and we have DCE. We want to prove they are similar. Well, let's use angle-angle again. We know for certain that angle B is congruent to angle C because they're both right angles, because all right angles are congruent. Now, where are my other pair of angles going to come from? Well, I have a pair here, and I have a pair there. What kind of angles are those? Angle AEB is congruent to angle DEC because those are vertical angles. Vertical angles are congruent. So that means that triangle ABE is similar to triangle DCE by angle-angle similarity. Those two triangles are congruent. I have one angle, I have my other pair of angles, so therefore the triangles are similar. Notice we didn't have to prove congruence, we just had to prove similar. Okay, now the majority of the time, and you have a step-by-step proof, when you're trying to prove a triangle similar, it's going to be angle-angle. So let's see if we can use angle-angle to prove these triangles congruent, or similar, excuse me, not congruent. So I'm going to do just like I do with the congruence one, I'm going to draw the triangles out separately. All right, here's PRS, so I'm going to draw this separately. And I want it to correspond to PST, so I'm going to draw them exactly the same way and label them exactly the same way. So PRS, oops, I'll do this one up here, PRS, and then PST would be the two triangles. Okay, those are the two that I'm trying to prove similar. So I want to prove angles about them. So let's start with the first given. We have PR is perpendicular to RS, and PS is perpendicular to ST. That's given. So PR being perpendicular to RS gives me what? Well, it gives me right angle PRS. That's this angle right here. And then PS being perpendicular to ST gives me this right angle right here. So that means angle PRS is congruent to angle PST because perpendicular lines form congruent right angles. So there's one pair of angles that I have congruent, and I'm set. So I've used this given, I've used that given. I have one more given. I have that PS bisects angle RPT, and that's given. All right, so angle RPT is right there and PS is right there. What does a bisector do? Well, a bisector divides an angle into two congruent angles. So if RPT is being bisected, that means that RPS and TPS are congruent. Well, let's see. RPS is that angle right there, and TPS is this angle right there. So let's put that down. Angle RPS is congruent to angle TPS. And the reason for that, a bisector divides an angle into two congruent angles. So, have I proved that two pairs of corresponding angles are congruent? Well, let's see. I've got one pair here with the right angles. That's right there. And I've got another pair here with the bisected angles. So yeah, I proved those two triangles are similar. PRS is similar to triangle PST because of angle-angle similarity. Those two triangles are similar. Notice I didn't say congruent, I said similar. All you have to prove is two pairs of angles are congruent to prove the triangle similar. Alright, so now let's see if we can figure out some values about the length of the sides. I'm going to draw my two triangles out separately again. So my first triangle was PRS, and my second triangle was PST. So here's the two triangles, and we just proved that they are similar, they're not congruent. So if I label them exactly the same way I had them above, PRS, and then PST. All right, let's fill in the values. We have PR is 9, PS is 10. Well, we also have PS over here, and then we have PT. Now, remember what we learned about similar triangle sides. These sides of similar triangles are in proportion. So when we set up a proportion here, we want to make sure we set them up exactly the same way. Are in proportion. They have the same ratio. So I'm going to set up a ratio of the sides of one I know and one I don't. So I have PR. What side does that correspond to? That's PS. So I can set this up as PR is to PS. Now I want to set up a second ratio exactly the same way, except I want to use the one I don't know. Well, PS is in this triangle, and then PT is in this triangle. That's the side I'm missing. So PS is to PT. Notice this one to this one equals this one to this one. The same ones have to be across from each other. Plugging in your values, PR is 9, PS is 10. This PS is 10 over X. Cross multiply, 9X equals 100. Divide by 9. And rounded off, this comes out to be 11.111. So approximately 11.1. So the length of PT would be approximately 11.1. So, when you prove triangles similar, you can do it by proving angle-angle similarity. Prove two angles, the triangles are congruent, the triangles are similar. Once you do that, you can say that the sides are in proportion.